Hello, welcome to this video presentation about CARLSON SurveyGNSS, VRS for static. My name is Rob van Etten, I'm with CARLSON Software. Let's get started with CARLSON SurveyGNSS. I'm gonna open a new project, so I'm gonna say new project, and let's just give it a name. I can also load a template, which is something new in the CARLSON release. So I'm also going to open a template. The template will just include your settings, for instance your coordinate system settings. And I'm also going to load a raw data file, a Rhinex file. Let's take this one, and then zoom extend, zoom out a little bit. You see that we are somewhere north of Boston. Now what I'd like to do is this is my rover, and it now has approximate coordinates, and I want to fix this station, so I want to have known coordinates. So what I do is I'm going to published observations. What I've done first is I've selected course as a setting, so I'm going to look for course reference stations in a 80 kilometer range, so that's about 50 miles. So I'm going to find the course stations in a 50 mile radius. So search published observations. Okay, there we are. So these are the course stations in the 50 mile radius. So what I'm gonna do is I'm gonna select the closest one. So that'll be this one, this one, this one, and this one. Let's say the four closest one. The closest one is at 25 kilometers. That's about 15 miles. So I'm going to take this one, and this one, and this one, and then this one as well. You see this distance is 50 kilometers, but this one is over here, which is not located so ideally. So I'm gonna select the one over here. And I'm going to bring in the stations. So now we're actually bringing in the data into our project, into our SurveyGNSS project. So there we are, 4 stations, and let's close this down. Then I have my 4 stations. Now we have a little issue, because the stations are 15 miles away, 15 miles or more, because the closest station is 15 miles away. And looking at my data, I actually see that I only have 5 minutes of data, which is not a lot. And since I have a 10-second interval, I only have 30 observations. So for baselines at 15 miles and more, I would need more data, more than these 5 minutes. I'm not saying 5 minutes will never work, but usually I want to be on the usually I would need more data for a 15 or 20 or 25 mile baseline. So so the question is, how can I bring the course stations closer? How can I sort of decrease the baseline length? Well, of course I cannot physically bring the course stations closer, but what I can do is I can compute a local base very close to my rover point, and that's going to be my VRS, my virtual reference station, which is more or less the same as the VRS that you have for RTK, only then it is real time and now it is for post-processing. And since it's for post-processing, we're actually going to create a file, a Rhinex file. So the Rhinex file itself is not a virtual file. That's actually going to be a real file. So we'll just select this option, and it's the virtual reference station. I have to mention that this is a separate module, so this is not in the standard version of SurveyGNSS. This is a separate module. So we'll select it, and then the software will find the three closest stations, which are these stations. And what is important, not only that you use the closest stations, but also that your unknown station is in the middle of, let's say, the triangle formed by the selected core stations, which is okay here. Okay, so we're going to use these stations. We're going to right click and we say compute VRS. So what will happen now is a new station, a virtual station, will be created using the data from the three closest core stations. So it's already done that. So if we go to positions now, we actually see that we have a new, let's get this, let's change this a little bit, make this a little bit wider. So you see that we have created a new station, a VRS station. It's named after the rover, but it's called VRS. And as you can also see, if we go to observations, that this is an actual file. So you see we have an actual file that was created, and that's a file that you'll have on your hard disk. So it's really a physical file. Now if you go to the vector calculation, you'll see that it now has calculated the vector between the VRS station and our rover station. And you can also see that the VRS station is 3 meters away from my rover. So 3 meters, that's about 10 feet. So unfortunately we can try to zoom in, but you could see, well, we cannot zoom in any further now, but these stations are really nearly on top of each other, only 10 feet away. And because this baseline is so short, I now have an excellent solution. I have a fixed L1 solution. It's high quality, 100% fixed ambiguities, so it all looks perfect, except for one little thing here. I see that I only have 8 satellites, which is a little bit disappointing, because I would expect GPS and GLONASS to have about 10-12 satellites. So the problem here is I have, for my rover station, I can go to view observe satellites. For my rover station I have GPS and GLONASS, but for one of my core stations, namely this guy over here, if I look at the observed satellites, you see it doesn't have GLONASS. So the only way to have a GPS and GLONASS solution is when all your core stations are also GPS and GLONASS, which is not the case over here. So in order to solve this, I'm just going to replace this ZBW. I'm just going to click on it like this, and I'm going to replace it by FMTS like this. And then I'm going to say compute the VRS again. So now the VRS is computed again using another station. So let's see what happens now. If we now go to vectors, you see that we have 12 satellites. So we have GPS and GLONASS now. We can also check our virtual reference station. and see the observed satellites, and you see we have GPS and GLONASS now. So this is now my final result. So using a close by virtual reference station, in spite of having only 5 minutes of data, I now have a very precise solution. So this is really a great tool. Gives you great flexibility, even if your core stations are further away. So this is the result in meters. I've been working in meters now to make it a little bit easier on myself. But as you know, you can also of course select feet. So let's quickly do that at the end of this presentation. We'll just ignore this, and now we have our result in feet. A few closing remarks. The VRS solution is a great tool, but you have to be aware that the stations shouldn't be too far away. I would say 50 miles would be okay. They also have to nicely enclose your unknown station, which we had in this case, and also the ionosphere is of course very important in GPS in general. So if on the particular day of the measurement you would have large variations in the ionosphere, the VRS solution might be a little bit problematic. So that's just something to keep in mind. But overall, this is a great tool, works very quick and gives you great flexibility. Thank you.